Hi everyone. So next talk, we have Diomedes Spinellis here, who will speak to us about how they found the V4 tape and uploaded that in the Unix History Repo.
Thank you. Hello, good morning. As you know, Unix has defined the way modern computing works. It was developed in the world-famous AT&T Bell Laboratories. That is a place associated with no less than 8 Nobel Prizes and 3 Turing Awards. And yet it started its life out of a failure. AT&T, General Electric, and MIT were building a system called Multics in the 1960s that was a bit too ambitious for the capabilities of the time. So AT&T pulled out of the project. It wasn't going too well. And Ken Thompson and other scientists found themselves without a subject of studies. So Ken Thompson, later joined by Doug McIlroy, Jeff Osana, and Dennis Ricci, went on and developed first a non-named system on a PDP-7. It has some very interesting ideas in it. And based on the success of that system, they created a funding proposal to Bell Laboratories. They needed to do that even in that well-funded place for a more powerful computer. Initially, they asked for a PDP-10, which cost about $500,000 at the time. Bell Labs stalled at the cost, and at the end they got a PDP-11, which cost a tenth of that price, and maybe the lesser capabilities of that system influenced the direction of Unix. Over the 1970s, a large group of people, you see them here at a later age, they were very young and powerful at the time, they developed on and created a series of Unix editions. These were numbered following the editions of the manual that came out each time. In various states, you see here the 7th so-called Bell Labs Research edition, from the first one to the 7th one. So source code was not versioned. Even at the last edition, there was no version control system, but the manuals were versioned through their printing and adding an additional word on it. Not a lot has survived from the first edition, so for the first unnamed one, it has survived in printed form, and people have OCR'd it in order to make it run. In others, when you see we have some parts of commands, some parts of the kernel. At the 4th edition, we had just the documentation. Which brings me to 1974 and this letter from Ken Thompson to Marin Newell at the University of Utah, which says that we are delaying the delivery because we ran out of copies of the documentation, but they will soon send you the system. Newell, you might know him, is the person, a British-born computer scientist specializing in computer graphics. He's the creator of the famous Utah T-port, a benchmark used for 3D rendering. So it seems at some point there was a version that could be shipped from Bell Labs to Utah. And something like this tape, this is a replica, and it's not the original tape, but I want to show you for those who are not familiar with the computer tapes, got shipped from Bell Labs to Utah. Fast forward to 28th of July 2025, and the storage closet of Robert Ricci's Flux research group at the Merrill Engineering building you see here, where Aleks Maricq, a research associate in the group, found the tape among the documents of Jay Lepreau. The findings was widely reported, even on broadcast TV. So was there anything on the tape? It was important to read it, but also it was one tape. We never had access to it before, so it was considered very valuable. So to avoid high-altitude cosmic radiation on flights and airport scanner damage, lab members Joe Duerig, that you see at the center, and Thalia Archibald, you see on the left, undertook an 11-hour drive to the Computer History Museum in California. There, it was read by archivist Al Kosov of BitSavers, a famous archiving site. You see him here at work. To minimize tape wear, he used a system developed by computer historian Len Shashek. So he first read the tape, not as a digital bits, but as a 1.6 gigabyte of analog data using a multi-track analog to digital converter. This means that a lot of hardware that you see here on the left that happens inside, that is implemented normally inside tape readers, can be implemented in software, and thereby the tape can be virtually read again and again with various settings so that it can be restored. You see here the waveforms from various tape tracks, and here zoomed in to see how they can be seen and various elements, how they can be adjusted. This was successful, and now if you go to archive.org, using Shustek's read tape program, this 1.6 gigabyte analog data were converted on 2.5 megabytes of digital tab format, which is compatible with a CMH emulator, and both are now available on archive.org. Think of it, the tape is 2.5 megabytes, about the same as a single picture we take with our mobile phones. What's the legal status of this tape? Thankfully, in 2002, Caldera, which owned the IP rights to Unix at the time, wrote this letter, which if you squint well enough, looks like an open source license. So effectively it can be uploaded on GitHub and shared and built upon and run and so on. And then people started using it. For example, Brian Rodriguez wrote this ebook, the Unix 4th edition source code commentary, where he analyzes the entire kernel and how it is built, how you can run it on an emulator, following a very influential book from the 1976 by John Lyons from the University of New South Wales, which taught many generations of computer science students the design of a real operating system kernel. Also, Angelo Pappenhoff, who gave a very interesting talk at 39C3 a few weeks ago, made it run on a PDP-11 emulator and also published a tar file with the tape's contents. I employed that file to add the tape's contents to the Unix History Repository. What is that? It's a repository on GitHub, on the URL you see there, that contains a history of Unix from its inception, so the first unnamed version, until today. For a lot part of it, it traces the 7th research editions, work that happened at Berkeley, the BSD editions, 386 BSD, and ends up with the FreeBSD modern editions. From the very complex and long history of Unix, it traces one line, the one you see here in orange. It contains snapshots of the research editions and various Berkeley editions, then commits moved from SCCS, this was the source code control system used for many years at Berkeley, and then finally normal FreeBSD commits as they moved from CVS to Subversion and now Git. The way it is constructed allows us to run git blame on it. Here I do it on timezone.c. And amazingly, we see on the modern FreeBSD timezone.c lines that were apparently written by Dennis Ricci in 1979. Actually, some of you may realize that those lines shouldn't be there because what was released by Berkeley was supposed to be a complete clean source, open source re-implementation of Unix, so this is a mystery to me. To add the contents of the tape to the repository, what I do is, what I did was, first of all, associate files with actual authors based on documentation and the information that was available at the time, even oral histories and things that people who were there told me now. And I got the timestamps from the actual timestamps of the tape, and each timestamp is a separate commit. Let me demo you how the system works. You can go to unixv4.dev and see it running. This is not the work I did, but I find it pretty cool. And it shows a Unix system that's what we expect. So if I type on the command line, I can change directory to TMP. Run the line editor. It's what happens when you press on Vim Q. I append lines, and I write a small main function with a hello world that you would expect. I press dot to finish my input. I write the file to hello.c, and then I can compile it. If I list the files in the directory, I see na.out, and if I run it, presto, I get hello world from code that was written at that time. So this is really important because now we have it's the first complete Unix distribution. We have the kernel, the commands, we already had the man pages, and the C compiler. This version introduced many interesting things. Structured programming, so kernel was implemented in a language called New B at the time. You can guess which language this was. 7,800 lines of New B and just 1,000 lines of PDP-11 assembly. It provided, I think for the first time, a language-independent API. So you see here the pipe system call, documented both in the way you call it from assembly language, R0 and R1 are PDP-11 registers, and from C to get an array of 2 file descriptors. It used the data structure definition and reuse through header files. It provided the device driver abstraction through special files. Many of the files are completely nonsensical today, speech synthesizer and the spider interface. But the driver interface, the way this abstraction was implemented, is still available today in FreeBSD editions, but also similar design on Unix and even on Windows if you try to write a Windows device driver. Also, it had a properly typeset manual. You see the third edition is typewriter. The other one is typeset. It had a Snowball implementation, a dynamically typed string and pattern processing language that has influenced Awk and Perl and thereby Python. 1,600 lines of C, and to try to find out why it was written. It was just a quick entertainment for Ken. And the application that survived was a program that solves the instant insanity puzzle. Here you see it written in Snowball. What are the tape's contents regarding dates? What I did, I created rain cloud diagrams from the files of all editions that have survived. And as you can see, the 4th edition, the files match, many of them match the manual page. Some are associated with a later date, but they seem to be relatively close to the manual date. I also wrote a script using Git blame to see what code was inherited from previous editions. And as you can see, the 4th edition inherits some parts of the 3rd edition, and also the 5th edition inherits a large part of the 4th edition. I also looked at the evolution of language use because it was a time C was being used more and more, and you can indeed see here that the 4th edition contains a significant part of C code, something that continues and gets expanded until the end of the decade, and I think we can be fortunate to say that it survives until today. Thank you very much.
So we have a couple of minutes for some questions. I see you here.
Thank you very much. I volunteer for a computing history group in Newcastle, UK. And about 10 years ago, the retiring head of school handed me a tape, and he said, "This has got Unix on it, I think."
Wow.
I wouldn't get too excited because I'm fairly sure it's well known. It's V7 or something. And obviously, the next thing I need to do is go back to him and ask him, because I can still contact him. But assuming there is something of historical interest on it, what would you advise our next step to be?
Contact the Computer History Museum to get further advice. We may be witnessing history here.
I'm surprised, but thank you. Okay.
We'll see. Thank you very much for bringing this up. Reading all tapes is tricky. They can get destroyed, so please don't touch it. For example, the tape drive used doesn't have any plastic parts, capstans, and so on, in order to minimize wear and tear.
When converting the binary data, when converting the analog data to binary, how did you make sure that there were no errors in the transformation?
So I didn't convert the tape, I just uploaded it on GitHub. But when the binary data were converted, how to ensure there were no errors, there are, as I understand, CRC checks in the tape reading mechanism. And then people actually looked at the tape contents to see that it was okay. So 2.5 megabytes is fine. And indeed, we found some, people found some blocks that were mislaid and manually patched them to correct everything.
Amazing, cool.
We are on time, but let's take one more question, and then we'll move to the next talk.
Hi, thank you for this amazing research. The POSIX standards came out in, I think, 1988. I was wondering to what extent does this very early incarnation comply to the later POSIX standards? What is, to what extent does this feel like a real modern Unix?
To what extent does it feel like a real modern Unix?
Yeah,
you see
and
there are
how
differences. For example, I typed CHD rather than CD. Many of the tools are already there. Command options are missing, and some tools are not there yet.
And the kernel, like the system calls that were later defined in the POSIX standards, they're still being developed at this point, I guess.
Thank you for, so what happened with the interfaces and the system calls? There is this, paper you can find, that documents in the repository on GitHub, that has a timeline of all Unix facilities, commands, system calls, when each one appeared, and when some of them also moved away. And there you can find the exact timeline and see what was there and how it compares to the 7th edition and later ones.
Very impressive. I'm going to look that up. Thank you.
Thank you. Thank you again.